Welcome all my dear students to Sudharma's Physics classroom. Today we are going to learn a very interesting and important topic in physics, and it's refraction of light. We have already learned the phenomenon of reflection of light, and we learned the reflection from plane mirror and the reflection from spherical mirrors and the image formation, right? So this is another phenomena exhibited by light that's called as refraction. So before knowing what is refraction, let me show you some examples here. So here in this particular picture, see this boy says that I aimed the arrow at a fish, but what I got was a frog. Observe the diagram carefully and think what happened in this case. So we have a fish and a frog here, and he was aiming at the fish, and the arrow went and hit the frog, right? Why this happened? Another example or another experiment we can conduct at home is this. See, a lot of pencils, a lot of color pencils kept in a tumbler containing water, and you can see the pencil bent. Actually, when you take it out, you can see it is not bent. I have made a separate video on this experiment, and I'll be giving you the link of that video in the description box. Go and watch that video. So everything is clearly explained in that. Okay. So why this phenomenon is happening? Why it looks bent? And the interesting thing is you can see here different colors are there, right? These different colors bends differently. The extent of bending or extent of shift happened to the image, right? That is different. Okay. So something is happening to this, right? Something is happening to the light coming from these pencils. So it's nothing but the refraction of light. So what is this refraction? I started saying the topic refraction of light. So now you will be having some idea in your mind. So let's see the medias I'm using here. See, there is air, right? The pencil, some portion of the pencil is in the air, and another portion is in water, and some portions if we are observing through glass, right? So there are three transparent media. This is very important. Okay, transparent. What do you mean by transparent media or transparent medium? Transparent medium means a medium which allows the passage of light, right? It allows the light to pass through it. We have seen in reflection of light an opaque substance, right? It will not allow the light to transmit through that. So that is an opaque substance. But here it should be a transparent media, or light should enter from one transparent medium to another transparent medium. There will be a difference in the path of light that is called as refraction of light. Very important. You need to learn the definition. Okay. So here it's very clear. The laser light, right, entering into a glass block, and there is another medium inside that, right? So the see two times it bent here. Okay, so it depends on at what angle the light is incident. Okay, so why this is happening? It's the difference in the optical densities that cause the deviation. Note down all the terms here. All these are important. When I say transparent media or transparent interface, we have to use that word regularly throughout this chapter. Transparent interface. Interface means there is a separation between two media, right? That boundary, right? That's called as interface. Okay. So the difference in optical density, optical density is another term. It's not actual density. Density, mass by volume, right? It's not related with that. This is something different in optics. It's optical density. Okay, we'll learn in detail about that. No need to worry. Okay. So understand that if I say this example of glass, air, and water, right? So they are different media. Okay, they are different medias, and they will have different optical densities. When there are different optical densities, and when a ray of light entering obliquely from a one transparent medium to another, its path undergoes a deviation at the surface of separation. So this surface of separation, this is called as interface. Okay. So obliquely, what do you mean by obliquely? There are two ways to observe. Say, this is example itself we can take. If the pencil is kept perpendicular to this surface, right? If I'm keeping it perpendicular to the surface, definitely we will not see it bent, because we are going to observe from above. So if I'm observing from here, I will not see any difference in the structure of this pencil. But what I have done is I am observing from another position at some angle which is less than 90 degree. Okay, a small angle. So I am observing it obliquely. Okay, that is also important. So we can define refraction as it's a phenomenon where light entering from one transparent medium to another transparent medium undergoes a difference in its path, or it bends. Okay, that is the phenomenon of refraction. So, in reflection of light, we have already discussed about the terms there, right? The incident ray. Here we have the refracted ray. Okay, incident ray, refracted ray, and the normal. So, what is normal? Normal means the position or the point where the incident ray strikes the medium. So here we have the interface here, right? This plane surface, right? We can see the water surface there. That is the interface. Okay. So there is a position where the light ray hits the interface. Okay. So that is called as the point of incidence. Okay. And instead of reflected ray, we have the refracted ray. Hope you are understanding. Okay, so when light enters from one transparent medium to another transparent medium, there is a difference, or there is a deviation in the path of light at the interface of two medias, right? That is called as refraction of light. Now, why this is happening? What is the cause of refraction? We know that the speed of light in different medias are different. Okay, so mainly I'm talking about three medias here: vacuum, or even we can take air. Okay, air or vacuum, and water and glass and diamond. Let's keep it pending for some time, because we don't normally don't take it regularly. But air, water, and glass, right? This is something which we see every day. So that is why even I have taken the example of that experiment with the pencil. We can do science experiments, we can conduct experiments at home. We need not go to the laboratory always, right? We can conduct and try and learn the scientific concepts. Okay. So the cause of refraction is, you just observe this table here. The speed of light in air or vacuum is 3 into 10 power 8 meter per second, and the speed of light in water is 2.25 into 10 power 8 meter per second, and in glass it is 2 into 10 power 8 meter per second. See, these values will be by heart for us by the time we finish this chapter, because we will be using these values multiple times throughout the chapter. Okay, so that means these values are really, really important. So have a look at these values. So we can see the highest speed is in vacuum or in air, and then in water, and then in glass, then diamond. This is a special one, because in diamond light has the least speed. Okay. So we can say that the characteristic of each medium influence the speed of light that passes through the respective medium. So optical density is a measure that shows how a medium influences the speed of light passing through it. So when we say optical density, what term we can use it, right? There is a surprise coming in the next chapter. Okay, so I will reveal the real name of that term in the next chapter. Next video. Okay. So today I'm covering the basic concepts of refraction. Okay. So keep waiting for the next video. Okay, to understand what is that term, what's a special name for this optical density. So I'm going to give you some hint here. Okay, so vacuum and water, if I take, there is a much more speed in vacuum than in water. So if light enters, when light is entering from one medium to another, if the speed of light is decreasing, okay, if the speed of light is decreasing, then we can call it as a denser medium. Denser medium. Still we didn't learn what is the term for that optical density. Okay, keep that in mind. That question I will ask you in the next class. We will learn about that in the next class. Okay, so we are going to learn two terms. One is denser medium and the other one is rarer medium. New terms are coming. Okay, make a note of it in your notebook. Denser medium and rarer medium. Concentrate more because this is a little bit difficult part for most of the students. Concentrate. If you concentrate, understand, then it is going to be really easy for you. Okay. So, what is a denser medium? When light travels from one medium to another, if the speed of light is decreasing, then that medium is called as denser medium. That means when I take vacuum and water, right, the speed is decreasing in water. So, this is denser. This is when I'm taking these two pairs, right, denser. Water, vacuum is going to be rarer medium. Okay. Now, at the same time, if I take water and glass, if I'm taking this pair, so what is happening here? In glass, the speed is decreasing. See this 2.25, power of 10 is same, right? 10 power 8. So in glass, it is 2 into 10 power 8. That means its speed is decreasing. So glass is denser and water is rarer. Now you look at this comparison. See, here water, I'm talking about water. Okay, water was denser in that case. Now what happened? Now water is rarer. That means the same medium, depending upon the pair we are choosing, right? Its optical density, right? The comparison, whether it is a optical density is going to be a constant for a particular medium, but the denser medium or rarer medium, how do we decide that, right? That depends on the pair of media we are choosing. It's like how we choose friends, right? So our enjoyment, our comfort level depends on the pair we are choosing, right? Or the friend circle we are choosing. So similarly here, whether it is a rarer medium or denser medium, it depends on with whom it is, right? So when water is with vacuum or air, water is denser. When water is with glass, then water is rarer. So the same material, right? The same medium, the same transparent medium, it can be denser medium or rarer medium with respect to what it is paired. Okay, so that means it is a relative quantity. But optical density is a constant for a particular medium. So there is a relation between optical density, rarer medium, and denser medium. So wait for the next class, as I said already. Okay. So the cause of refraction is the change in speed of light when light enters from one medium to another medium. Now, when we draw the ray diagram, see in light, in optics, ray diagrams are very, very, very important, right? We have practiced all the ray diagrams for the mirrors. So when we draw the diagrams for refraction of light, we have to mark a straight line that represents the interface or the boundary. Okay, so what is boundary? What is it? The border between these two transparent media. Hope you remember how we marked the mirror, right? Mirror we had to mark like this, right? One side, right? One side is reflecting surface, the other side we mark like this. This is a mirror. So when you draw a straight line like this, that means it is a transparent interface. Okay. So let's see the first diagram. So here we have the point of incidence. Okay. So normal is drawn at the point of incidence. So air and water. Let's try to recall what is the rarer medium and denser medium. So air is rarer. Air is rarer and water is denser when we take this pair, right? So when light travels from a rarer to denser medium, light will be bending towards the normal. Very, very important. Put a danger signal and write it down. Towards the normal. Towards the normal. This rule we have to follow when we draw the diagrams of refraction. So when light travels from a rarer medium to a denser medium, light will be bending towards the normal. Now the second diagram. See the arrows. Arrows are very important in optics ray diagrams. See the second diagram, the arrow is this way, right? This is coming from glass to air. So remember what is the speed of light in glass? Speed of light in glass is 2 into 10 power 8 meter per second, and in air it is 3 into 10 power 8 meter per second. So air is rarer and glass is denser. When I write this, you will come to know something very important here. All the cases, air is becoming air or water, air or vacuum, it is the rarer medium because light travels the fastest in vacuum or in air. In air, slight difference will be there, but generally in grade 10 level, we discuss about air and vacuum almost same. Okay. So glass is denser and air is rarer. So what happens here? The light rays bending away from the normal. Away from the normal. Okay. So when light travels from rarer to denser medium, the light will be bending towards the normal. And when light travels from denser to rarer medium, it will be bending away from the normal. Third situation. Third situation is it just strikes the interface normal to the surface. So this is called as normal incidence. Normal incidence. Normal incidence we have seen in the case of mirror also, right? If the incident ray strikes the surface perpendicularly, the angle between the ray and the surface is 90-degree, right? That is normal incidence. So as we already know the angle of incidence, here angle of refraction will be there. Okay, so this is angle of incidence and this is angle of refraction. So we can measure that, always measure the angle between the normal and that particular ray. So here it is incident normally. So the normal also lies on the same line, right? This incident ray, refracted ray, and the normal, everything is in the same straight line. So there is no angle, right, created between the normal and that particular ray. So we can say I will be equal to R will be equal to 0 only in the case of normal incidence. Okay. Remember, I'm talking about this only for normal incidence case. That's a separate 1 mark question. If the ray is incident normal to the surface, what is the angle of incidence and angle of refraction? So in that particular case, that's a special case, the light ray goes undeviated and both the angles will be 0. Question, the diagram number B, then here the light is traveling from glass to water. Tell me what is denser medium and rarer medium? Just think for a second. Glass is denser. Water is rarer. So what happens? Denser to rarer medium, the light will be bending away from the normal. Again from glass to water, denser to rarer medium itself, but it is a normal incidence condition. So it moves without bending. Okay. So hope you understood what we have discussed today. So we learned why this boy is not able to catch that fish. Because try to answer that question yourself. There is a shift in the position, right? We have seen the light is bending. So when light is bending, the image formed in our eye, that will not be the actual position of that object. So what we see is the image of the fish. Okay, this boy is seeing the image of the fish, and actually where the frog is located and its position, that is different. Okay, so we are not seeing the actual position of the object when the object is immersed in a liquid inside a pond. Okay, so that is the image position will be somewhere else. We will be learning how to draw the ray diagrams for this also. So the reason behind this phenomenon is the reason behind he couldn't catch the fish is refraction. Okay, so this experiment, you watch this experiment, I'll give the link in the description box. Okay, so you can even try. See, there is no other lab equipments required here. We need a glass tumbler, water and pencil. See, it need not be a pencil like this, any pencil or pen, anything in a stick. You can observe and see. When you do that experiment, what you have to do is you just see from different angles. Okay, see, since this is a picture in the video, it's really clear. I took the video from different angles. It is very clear in that. And even when you're doing it, you can observe from different angles, especially you observe from the top of that tumbler. Okay, so see what is happening there. So enjoy and learn this chapter. Okay, it's very, I mean, real life related chapter. Hope you enjoyed the class. And in the next class, as I said, there is a surprise term waiting for you. So stay tuned till the next class. So in the next class, we'll be discussing the laws of refraction and some surprises in that. Okay. So if you are watching this channel for the first time, please subscribe to the channel and click the bell icon for more updates on classes. The advantage if you subscribe and click the bell icon is, as and when I upload the class, you will be getting the notification so that you don't miss any classes. Okay. So see you in the next class. Thank you for watching. Bye.